Is first write down the squeeze theorem. I'm not going to talk to you as you write it down. We'll digest it once you get it all figured out. All right, once you get it all written down. Excuse me. Draw the picture. I will let that be up to you. If you think it would help, draw it. So what this is saying is maybe we have a limit that we can't take. All right? Function f, we're having trouble algebraically determining what that limit is. If we know a function above and a function below, and we can squeeze f in between like a sandwich, then we can evaluate the f limit, evaluate the h limit, evaluate the g limit, and since f is squeezed in between, that can help us determine what our middle sandwich limit is. Okay. So like I said, you don't have to draw the picture, but if you think it helps get that overall thing. I'll tell you what, we're not going to use this very often, all right? It doesn't come up a lot, but it's kind of one of our fallback strategies, okay? If we can sandwich a function in between two other ones, then we can evaluate the limit of the bread, and that tells us what the limit is of the turkey. Okay, there's my analogy. My family likes turkey. Okay. So we're going to do a quick example, and then we're going to get to some trigonometric limits. Okay. May I move to the next slide? Is everyone done ready? Good. Give me a thumbs up. Okay. So we want the limit as x approaches 0 of x sine of 1 over x. Okay. Well, if we try to plug in 0 analytically, what happens? Okay, we have a 0 in that denominator, right? Let me see what's happening here. Okay, we cannot analytically figure that out. Also, the graph looks like this. We get like some little squiggles in there. Okay. So we need to squeeze this in between two functions. So this is what we can do. I know that the sine of x, or the sine of 1 over x, its range is always going to be negative 1 to 1, right? The output of a sine function is going to be from negative 1 to 1. Do you agree? Okay. So what we can do is the absolute value of x and the absolute value of y. Ooh, that graphed that a little bit. Would sandwich that equation, all right? This is always going to be between negative 1 and 1. And so the absolute value of x, so between negative 1 and 1 times x, is always going to be underneath or in between the absolute value of x. So what we can do is, okay, since this function is in between the absolute value of x and the negative absolute value of x, we can evaluate the limit towards 0 of the outer functions, and that can tell us what the limit is of this wonky sine function. Okay. What's the limit as h approaches 0 of the negative absolute value of x? The negative absolute value of x. As we approach 0, where's our y? At 0. What about the limit as x approaches 0 of the absolute value of x? Okay. Well, since those are the same, and this function is sandwiched in between, what must the limit towards 0 of this guy be? 0. Okay? As long as these limits match up, then the function in the middle must have the same limit, right? Okay. Now, I'm not going to ask you to have to come up with those functions. I'll give you a sandwich to evaluate, essentially, a sandwich of functions to evaluate to apply the squeeze theorem. I'm not going to just like make you pull this out of your back pocket and like think of equations that sandwich a function. Okay, so take that off your worry list. Okay, it will always be presented to you in a very nice fashion. Okay, now if you go on to like study mathematics in college, probably something that you'll want in your back pocket, but for this class at least, I will always give you the 3 inequalities to look at. Okay. All right, let's switch modes here to some trig functions. Go ahead and write down these 2 examples. The limit as x approaches pi over 3 of secant of x, and the limit as x approaches pi over 6 of tangent of x. Okay, we haven't talked about anything trig related. Guess what? We still get to use direct substitution. Here's where knowing your unit circle is going to come in handy. The secant of pi over 3. The secant of pi over 3. Turn to your neighbor and say what it is.
Yeah, so when you turn on C, you have one finger, so you want about your cosine. You have 1/2.
I'm eavesdropping. I hear people talk about 2. The cosine of pi over 3 is 1/2, so the secant is 2. All you have to do is plug it in. Direct substitution, we're done. The tangent at 5 pi over 6. First of all, is it positive or negative? Negative. Okay. Sine over cosine. 1/2 over radical 3 over 2. So we're talking about radical 3 over 3. Okay, just know your unit circle so you can do those direct substitution problems. Okay? All would be right in the world if that's all we had to do, right? But what do you think? It's not always that straightforward, okay? We could have some situations where we have like that 0 over 0 situation. Gets a little bit weird with trigonometric functions. So we have 2 rules that I need you to remember. Write them down. I'll make them bigger because they seem small. The limit as x approaches 0 of sine of x over x equals 1 every time. And the limit as x approaches 0 of 1 over cosine of x over x equals 0 every time. There's really not a whole lot I can do for you but say you need to remember these special rules. Okay? Pay attention to what we're approaching and pay attention to the fraction. It is okay if they are inverted. Like if this was x over sine of x, that's okay. It will work the same. Okay? Because of the 1. All right? Now, write this down. This is our first example. The limit as x approaches 0 of sine of 2x over 2x. Does that look similar to the rule that we just wrote down? Yes. It does. Okay. What's different? The 2x. Okay. Okay, well, we can't, like, cancel out the 2's because this 2 is inside of the sign. We can't take it out. But as long as whatever is the angle for the sign is the same as the denominator, then the rule still matches, okay? That could be the sign of star over star, and it's still going to work, okay? As long as that angle matches the denominator, we're good. No, you're fine. I just want to make sure that you're good. Okay. Two examples in 9 minutes. I think we can do that, right? Yeah. I think so. Okay, I don't see a sine or a cosine in here. I said, well, yes, yes. So hold on. So we have 0 over 0, right? We don't like that, okay? I also don't see like a sine of x or a cosine of x to use either one of those special rules. But tangent is sine over cosine, right? Yes, you will have to use identities sometimes. Okay. Now, is that going to be helpful to me? Can we rearrange to make it helpful? Could I say sine of x over x? We like those groups together, right? multiplied by 1 over cosine of x. Do you see how I rearranged everything? I took sine and cosine and separated them, but I kept the denominator of x with the sine. Why did I do that? Because the limit as x approaches 0 of sine of x over x goes to 1. And when we plug in 0 for cosine of x, the cosine of 0 is 1. 1 times 1 is 1. Okay, I hear some whispering happening, and I don't know if it's like, oh yeah, I understand it, or oh man, I'm frustrated. Give me something to work with here. Thumbs up, thumbs middle, thumbs down. How do you feel about that problem? Okay, yes.
Why is it 1 times 1 at the end, not divided?
Okay, well, we have like this fraction times this fraction, right?
Yeah.
So I just said, 1 divided by 1 is 1.
Okay.
Does that make sense?
Yeah.
Okay. And you guys see what I did there with that arrow? Like if I evaluate a limit but I still have more to go, kind of made a note to myself. That limit goes to 1. Does that make sense? Okay. X is not always the variable we'll use, so here we'll practice using u. Oh, look at that. Is this the special rule? No. Turn to your neighbor. What would make it the special rule? Okay. Dylan, what would make this more doable? Okay, so you're saying since this is a 5u, it would be better if this was a 5u. Well, we can't just like throw a 5 up there, right? We have to multiply by a well-chosen 1. Okay. We cannot take that 5 out of the sign. It is stuck in there. Okay? Algebraically, 5u is inside of sign forever. You can't do anything about it. But what I would do is I would write this as the sine of 5u over 5u. I'll take that 5 and place it over here, times that 5. Right? All I did was rearrange. Now, this guy has a limit of 1. 1 times 5 is 5. If that's not your work, you are not getting there correctly. You're not getting full credit. Yes.
Kind of what I was asking. So, like, if you put 5 into the sign.
Yep. I will take off points for that. Yeah, algebraically, your work needs to be logical. Okay? We cannot take that 5 out. Oh, like this guy?
Yeah.
This guy you could. I'm sorry. I thought you were talking about this guy. No. Aha. This 5, yes, you could rearrange that and put that in front. I am sorry I misunderstood your question.
I don't want to miss any
I'm sorry. I am not that picky. Okay? This 5 is stuck in there. There's too many 5s floating around here. Okay. So here is the deal. Okay? You do have a couple more difference quotient problems tonight, in addition to the ones from last night. So that's where we will like kind of bring our attention to first tomorrow as far as our homework is concerned. Then we will talk about all of these trig limits from your homework as far as like questions. And then tomorrow we're going to talk about one-sided limits. Okay? So revisit your difference quotient problems. You've got it. We can do it. It's the algebra that's tricky. And that's okay. Yes.
The bell's back to ring, so
Yeah.
need to go.
Take your back.
Well, I'm not gonna take 5 minutes.
Well, we have 2.
No, we have 5.
Looks like
I thought we get
it's
it.
Apple Day.
Oh.
It's Wednesday. We get out at 43, right? 43.
I don't know if anyone is complaining. Maybe you're pretty.
It's 43.
Thank you.